Okay, for the past couple of weeks we've been talking about functions in Algebra 1, and we are going to finish up the unit by talking about some applications of functions. There's a couple things here on the table, and then we're going to do a couple examples. So, functions in the real world. Functions help us describe some sort of real-world phenomena. We can determine a pattern and come up with an equation to help us evaluate for different inputs. Okay, so our example here is Francisco earns $9 a week for his allowance and gets paid $10 per hour for work each week. Write a function f that models the situation. We're going to go ahead and underline important information. So $9 a week plus $10 per hour for work each week. And we're looking at the total amount that he makes per week. So the function f is going to depend on how many hours he works, because he automatically gets that $9. Okay, so our 9 isn't changing each week. We're going to keep it the same. Okay, what is actually changing is the amount that he makes based on how many hours he works. So that's where we're going to put our variable. So our function is f of h equals 9 plus 10h. You could use an x there if you wanted to. Doesn't matter. I used h because we're talking about hours. Once we have that, even before we have that, we can actually find values at different inputs. So what we're going to do is we're going to use the function from the previous step to fill in the table. So if my x, maybe we should change this to x since that's what we have down here. So let's go ahead and fix that. Make those x's, x, h, same idea. Okay, so if my x is 5, that means I'm going to do 9 plus 10 times 5. If I type that in my calculator, I get $59. I'm also going to plug in 10, so 9 plus 10 times 10, plug that in my calculator, I get 109. 9 plus 10 times 15, if I plug that in my calculator, I get 159. And then plug in 20, 9 plus 10 times 20, I get 209. Okay, so what we're looking at here is kind of what's our situation? How many possible hours could he work for our x values? What's our domain? Now, since it's not possible to work a negative number of hours, I know that my x has to be greater than or equal to 0. I don't have to pick 5, 10, 15, 20. I could pick 2 or half an hour, and so forth and so on. So that's kind of how we get that. Now, if I find my domain, now I'm going to plug that value in to find my range. So I'm going to do 9 plus 10 times 0. So if he works 0 hours, he is still going to make $9. So that means his range is going to start at $9 and go up from there. Okay, kind of tricky, but we're going to do that a little bit more. Okay, so if we are given an evaluated function, we have to know how to interpret it. Okay, so here's our situation again. Here's $9 a week for his allowance and get paid $10 per hour each hour. $10 per hour for each work each week. Wow. So this is telling me that he worked 12 hours and made $129. Okay, so very similar here. This is telling me he worked 30 hours and made $309. Okay, let's go ahead and look at the back side, and we're going to do some similar problems here. Okay, so here's our first example. The daily rental charge for renting a Buick at Rent-A-Wreck is $30 plus 25 cents per mile. Okay, the word per tells us exactly where our variable is going to go, so make sure you pay attention to that. Anytime you see the word per, we're going to use a variable next to that number. Okay, so it makes it pretty easy to write this out. My function is f of x equals, the $30 doesn't have the word per with it, so that's just a flat rate, it's not going to change. And then 25 cents is 0.25 times x. Okay, so there's our function. Now you're going to go ahead and plug in 50 and 100 and 150. So I'm going to let you go ahead and use your calculator to do those real quick. And see what you get there. Okay, so when you plug in 50, 0.25 times 50 is $12.50, plus $30 is $42.50. 0.25 times 100 is 25, plus 30 is 55. And 0.25 times 150 plus 30 gives us 67.50. Okay, so that's how much money it's going to cost if you drive 50, 100, or 150 miles. For our domain and range, it's per mile, so I can't drive a negative number of miles. So again, my domain is going to be x is greater than or equal to 0. And then to figure out what my y would be, I'm going to go ahead and plug 0 in. So I'm going to do 30 plus 0.25 times 0. So when I multiply that out, I end up getting 30. So no matter how many miles I drive, the cheapest the car would be 30, because I have to pay $30 just to rent the car, and then it adds per mile after that. Okay, last one, interpret the following. This gives us our miles and our cost. So drive 75 miles for a total cost of $48.75. If you have any questions, hit pause, go ahead and rewind it, look it over again, check with the teacher, and you can get some help if you have any questions. Okay, last one. A soccer ball is kicked upward from ground level. The time t how long it takes the ball, how long the ball has been in the air, and the function h of t is how high the ball is from ground level. The following function models the situation. So here's your function, giving that to you, you don't have to worry about it. So let's go ahead and plug in our values there. So we're going to go ahead and plug in 0.5, 1, 1.5, and 2. So when I do this, I'm going to make sure I plug it into each number. So I'm going to do each of these separately. Okay, so I'm going to plug each of those in. Negative 16 times 2 squared plus 32 times 2. Okay, and we're going to kind of do some calculations here. So you can type those right in your calculator and see what you get there. For the first one, I believe we should get 12. Okay, for the second one, we should get 16. For the third one, we should get 12 again. Interesting pattern there. And for the last one, actually get 0. Okay, interesting pattern. Let's think about this. The soccer ball is kicked upward from the ground level. So if the soccer ball starts at the ground, somebody kicks it up in the air, it's going to go up and then come back down. That's kind of the path it takes, right? So that's why we got the same height twice. Does that make sense there? Okay, so maybe one right there and right there. Maximum height there. When does the ball hit the ground? Okay, so if I start on the ground here, okay, so start on the ground here, kick it up in the air, hits the ground again, how long does it take to get there? That's when my height is 0. So it's going to be 2 seconds, and because the height is 0. Okay. Once you finish this, make sure you bring the completed note sheet up to get your homework. There are 2 problems on your homework that you need to try, and we will go through those tomorrow. You will not get your homework unless your note sheet is completely finished. Have a great day.